90% of coral reefs could disappear by 2050, and this is determined by Coral Guardian. So today you will learn what coral bleaching is in the Florida reefs. First things first, what is coral bleaching? According to the National Oceanic and Atmospheric Administration, NOAA, coral bleaching is when corals are stressed by changes in conditions such as temperature, light, and nutrients. So they expel their symbiotic algae in their tissue, causing them to turn a white color. So symbiotic algae is a symbiotic relationship between algae and coral. A symbiotic relationship is when two completely different organisms interact with each other, but they both benefit. So the algae lives within the coral's tissues, and when they expel this, they turn this white color, causing them to die in the end. So now that you have an explanation of what coral bleaching is, you now have awareness, and you're going to learn about its effects. So number one, its effects of coral bleaching creates a decrease in coral diversity in the reefs. So coral diversity is multiple different species of corals in a reef. So here we have a table of subregions in the Florida Keys, which the Florida Keys is our reef in Florida. So here we have multiple regions here, and as we can see in the lower reef, which has 1,666 colonies that they support, they also have the highest cases of bleaching. And according to Daniel E. Wagner, why this happens is because since they support the most colonies, they are more prone to coral bleaching. They have the most amount of species of coral there, meaning when the coral bleaching hits them, it hits them the hardest because more of them can change and more of them can get affected by it. So that's why the lower Keys has the highest amount of coral bleaching. Furthermore, looking at the zones in this section, we can see a notable difference between the inshore reef and the foreshore reef. With the same exact pattern set as before, the fore reef has the most amount of colonies that they support, making them the highest prone to coral bleaching because this mainly decreases their coral diversity. So all in all, by Daniel E. Wagner, he had a whole experiment and he determined that the greatest proportion and the highest cases of bleaching was in the mid-channel, inshore, and fore reef areas. So not only is that the coral reefs are being affected with their coral diversity, but now the water is also changing. Leading us into our second reason is that coral bleaching can affect the thermal temperature of the water. So here we have a photo of Florida and the Florida Keys. Here specifically is the Florida Bay. So the Florida Bay has higher temperatures near the corals instead of the surface. Why? Because by Derek P. Manzello, he states that there is a presence of inverse thermocline in the water. So inverse thermocline is the complete opposite of what's supposed to happen. Water is supposed to be hotter near the top because that's where the sun rays are hitting. But since there's an inverse thermocline, the water is now hotter near the bottom where the corals lay, causing them to have dense, salty, and hot waters, making them more prone to coral bleaching. Furthermore, we have a more specific zone, the MLRF, which is located right here, and this is the rate of seasonal temperature warming. So rate of seasonal temperature is also very important. Why? Also stated by Manzello, is that the temperature can lead to a decrease in the potential bioint being able to cope. So the holobioint is also another relationship that the algae and the corals have with each other. So the holobioint is that the coral is its host and there's multiple different organisms such as viruses and bacteria that stay with it. But when the water increases, the holobioint isn't going to cope with the stress. So all in all here, we have the thermal stress can create different factors and effects such as the NOAA photos that I have here showing the different effects that coral bleaching has on these corals. So this can cause coral disease and a decline in the reproductive output and coral calcification. So not only is the thermal and the temperature in the water affected, but now same thing with the coral ecosystem and the functions of it. So our third reason is that coral bleaching affects the ecosystem functions in the reef. So here we have the Disturbance Response Monitoring Program, the DRM program, which clarifies and shows the different effects of high-level coral bleaching events that happen. So here we have a chart that the DRM program examined the different functions and the different characteristics of a certain coral. So here we have the colony height, colony footprint, volume, and surface area. So as the water keeps getting hotter, as more coral bleaching is being prone, the changes keep happening all in here. So it examines the stony coral colony, which is a specific species in the coral right here. Furthermore, the colony size contributes to the reef. So here we have the surface area of the reef, because the coral size affects its reef architecture, which is the surface area. And the reef has a certain structure, a certain function, just like a forest, or just as something, our cities here, that the corals serve as a certain place for these species to lay, such as the fish and the invertebrate habitat. So when the coral bleaching happens, it gets rid of these corals and fish's habitat, making its function not as plausible. So in conclusion, there are multiple different effects that coral bleaching has on our reefs, but the three main ones is that it affects the coral diversity, the thermal environment, and its ecosystem functions. Thank you.